Hi Chem 20, it's Mr. Riley here. Just giving you a quick little video on looking at titration curves. So the last video, we did a titration experiment to determine the concentration of an unknown solution. So we had a solution of sodium hydroxide. We did a titration so that we could determine what volume of titrant we need to completely react with that sodium hydroxide. So we did that. We found our unknown concentration. Okay. So for this experiment, so please watch that other video first. This will make a little bit more sense. So in our experiment, what we could do with our titration experiment is we could graph the results of our experiment. We're going to build what's called a titration curve, and we're going to be sort of graphing what is happening in the Erlenmeyer flask. What is happening in the flask? So if I had a pH meter in that Erlenmeyer flask where my analyte or my sample is, in our case the sodium hydroxide, what would it look like? Okay, so my sodium hydroxide by itself is going to start out with a really high pH. So here we have, I think, pH 7, 1, 2, 3, 4, 5, 6, 7. Yep. And so it would start out with a really high pH. And so I would start my curve somewhere up here. And as I add acid, I'm neutralizing small amounts of that base. But I always have, excess base until I reach a point where now I've reached a point where they're equivalent. And if I add a little bit too much acid, and what you guys, if those of you who did the lab, if I add even one drop of excess acid, I'm going to go past my endpoint of my titration. That's where my color change happens, and I'm going to, I'm going to end up with an acidic pH, with an acidic solution. So up here, I would have excess base. I'm going to add acid slowly, and at the point where I have equivalent amounts of acid and base, I'm gonna immediately sort of drop my pH and to a point where I'm right in the middle of this vertical portion of the graph, and I make a point right here. This is called the equivalence point. Okay, so the equivalence point represents a pH, and it also represents a volume of titrant added. So, whatever you're adding, that's your titrant. And so in this case, when we have or actually really anytime you have a strong acid and a strong base, as long as they're, monoprotic acids and monoprotic bases, then your equivalence point is going to be right at neutral. It's going to be at a pH 7. When I have equivalent amount of acid, equivalent amount of base, they both entirely reacted, and I get a neutral solution. Okay, and so that equivalence point is going to be the point that we want to end our titration. So the end point of our titration has a connection to the equivalence point, but they are different things. Now, the equivalence point will also help us determine an indicator for our lab, our titration lab. So if I have a pH of 7, I want to find an indicator that is has that equivalence point within the pH range. So we chose bromothymol blue. So bromothymol blue has a color change range from somewhere here from 6 to 7.6. And so we want to choose an indicator that is going to have the equivalence point, the pH at the equivalence point within that pH change range, so that we can stop our titration. We can find our endpoint at that pH. So our endpoint for in the previous video, for the one that we did with bromothymol blue, was a pH of our endpoint was green. So we want to stop our titration when our solution turns green, and that's connected with the equivalence point at a pH of 7. And that equivalence point will tell me how much volume that I needed to add to that solution to neutralize it. And so there you have it. Now we could also have a titration curve. Maybe we have a titration curve that looks like this. So always on your x-axis, you're going to have how much titrant is added. And always on your y-axis, you are going to have your pH. Okay, so 7 would be in the middle here. Now, let's say I started, my sample or my analyte was an acid, and I had to titrate it with a base. So I would start with a low pH and end with a high pH. Okay, so this would be a strong base, or sorry, excuse me, a strong acid titrated with a strong base. Okay, my equivalence point for this should also be pH 7. Okay, now I could have a situation, where I have let's put my pH over here. Okay, titrant added. And I could have a situation where I have, let's say, a weak acid titrated with a strong base. So my weak acid, it's somewhere pH, 4 or 5 down here. Okay, and I'm gonna, let's put a title on here: weak acid titrated with a strong base. And so in this case, my equivalence point would be above pH 7. So I'd want to choose, a pH indicator that would have that equivalence point pH within the indicator range. Okay, so there's a little bit about titration curves. Hopefully that helps you guys out a little bit. Not my best video, but there you have it. Okay, hopefully that helps. Have a great night. Bye.